In the last video, we saw how when we start to create many classes, we can have a problem with storing them. Specifically, I have these two different types of classes, and I want to create a shopping cart that can hold both, because it seems like I can hold both those in a shopping cart array list. But array list has this constraint where I can only put one type of thing in. So if I make an array list of my phones, I can't put my pods in. And if I make an array list of my pods, I can't put my phones in. And if I have many other devices, I just compound the problem. So to solve this issue, the reason why we have the need for this concept called inheritance is to create a new class that maybe encompasses both these. And we're going to create one called MyDevice. Then I can create an array list of this MyDevice and put anything that's on MyDevice, which are phones or pods or whatever, into this array list for processing purposes. So that's the motivation behind this inheritance hierarchy or the inheritance tree. So before we do that, let's take a look at a MyPhone and a MyPod class. So here's my phone. And let me get a MyPod up here. And as you can see, they're very similar. They both have instance variables for memory and color. Carrier is different for a phone. They both have a zero argument constructor. This one does one more thing because of that third instance variable. There's a 2 argument here. There's a 3 argument there. There's the third argument. And they both have a toString. So the basic components of a class. So what I'm going to be doing to create this inheritance tree is to factor out, using the mathematical terminology, factor out the common elements. So as you can see here, memory and color are both common to both these classes. So those are going to be factored out, leaving my phone with just one. And you also see here there's common elements in terms of the constructors and probably the toStrings. So we're going to use this concept of factoring out information, namely instance variables and methods, factoring it out into the superclass. So let's take a look at this new inheritance type project with the MyDevice. So here it is. So as you can see, I have the MyPhone and MyPod, and they both point upwards to the MyDevice superclass. This upward arrow really means is a. It has to pass the is a test. A MyPod is a MyDevice. A MyPhone is a MyDevice. A baseball bat probably is not a MyDevice in terms of electronic devices. A car, probably not a device. These two are. Okay. So what's in there? Well, let's take a look at this MyDevice. If I open this one up, you can see that I've taken out the common elements. The memory and color were common. I factored them out into this MyDevice. Here's the 0 argument constructor, the 2 argument constructor, and a toString. Very common elements for both those classes. So if I factor it out, what's left? In the MyPhone, you'll notice that I only have one instance variable. The other 2 are in the MyDevice. And the key to this is to use the extends keyword. This actually draws the arrow upwards towards the MyDevice, as you can see right there. That keyword extends creates that arrow, as it does in MyPod as well. So that's a key element. I have a 0 argument constructor with this new word here, which I'll talk about. The 3 argument constructor with, again, the word super again. And a toString with another super. So what's this super business? What super is a call, specifically, it's a call to the superclasses constructor. So MyPhone, if you recall, had 3 instance variables. The MyDevice, get things organized here. The MyDevice class has a 0 argument constructor that initializes 2 things. Well, if MyDevice already has it done, I'm just going to ask MyDevice to run its constructor, namely this, and when it's done, I'll come back and do the third instance variable. MyDevice has a 2 argument constructor, as you can see right here. Well, my phone requires 3, so I'll say, hey, superclass MyDevice, can you initialize the first 2 for me? Run your 2 argument constructor, and then I'll take care of the third. So these supers are calls to the superclasses constructor. MyDevice's constructor. The second way I can use a super is with a dot. These are parentheses, this is a dot here. Super dot toString. This means, hey, superclass, run your toString method. Call the toString method from one class above me and run your method. And then when you're done, I'll tack on the carrier. Okay? And I think I need to add a \n here for a new line. Okay. run your toString method, and I'll add on after that the carrier. So I'm taking advantage of that the superclass has done some work, and I'm just going to ask the superclass to do the work. How about the MyPod? The MyPod's pretty clean because MyDevice has most of those things. It doesn't have any instance variables because they're right there in the MyDevice. I just call super because super will just run this code and initialize the two instance variables. The two argument constructor, I'm going to call super again and say, hey, superclass, you initialize two things. I get them, and I'm going to pass them on to you, and you run your code to initialize them. And as far as toString is concerned, I'm going to say, hey, superclass, MyDevice, run your toString, which will basically run that toString method here. So I'm just passing the buck. Once I get a request, or I'm asked to run a method, I'll just ask the superclass to do it. If there's anything else I want to do, I can tack it on at the end. So let's see how this works here. Let me close this up. Let's compile it. Actually, let's take a look at MyDevice driver. What did I do there? I created my phones and pods like in the previous one. Now you'll notice this is the interesting part. I'm creating an array list of not of my phones or my pods, but of MyDevice. Anything in this array list is a MyDevice, on my phone, on my pod, or my whatever else I create later. I can call it inventory and new array list of MyDevice. So now phones can fit in, pods can fit in, anything else that I create that's a MyDevice can fit in. So I'm putting seemingly different things into this array list, but they're really MyDevices. We call this polymorphism, or polymorphically traversing this array list. Polymorphically, many shapes. There are many different things in this array list, 2 to be exact, but it could be more. And I'm going to, in this for each loop, just run through them and print them out with not really knowing what device is in there. I actually know because I put them in there, but if you had a shopping cart, people were adding things in, as long as they were MyDevices, then they would fit, and I can, in this case, simply print them out or calculate totals, taxes, shipping rates, and all that business. Let me run this. And right here. And you'll see, this is the for each loop here. It's going to each item. This is a my phone. That's a 0 argument because there's no carrier. There's the 3 argument constructor, the 2 argument, and a 2 argument. So it went through that array list of seemingly different objects on my phone and on my pod, and ran their toString method, which is pretty simple, but it could be more complex with, as I mentioned, calculating totals, sales tax, shipping, or any complex algorithm. I don't need to know what is in there. I just run the method and I let each object take care of the details for me. So the steps to creating an inheritance tree, I use this word implementing, although it has a different meaning when we get into the next section with interfaces, but I'll use it here, is to factor out the common instance variables and methods. So I took out if you recall, the memory and color. So I factored those out, and methods. I created the link with the extend keyword. That creates the upward pointing arrow you see there. That actually creates a link. And then if I need to call the superclass's constructor, I use super with parentheses, either empty or with 2 arguments or 3 arguments, to call the superclass's constructor. Again, if the superclass has the code written, I'll just let it run its code, and then I'll take care of any other instance variables that I may have. I can also use super dot to call methods from the class above me. In this example, we saw toString. I could say, hey, superclass, run your toString method, and he'll run his toString method, and then I can do anything else after that that are details for my class. But again, using code that's already been pre-written. And the power of all this is to create arrays or array lists of this superclass object, and to run through or traverse the array or array list or 2D arrays of all these seemingly different objects, so I can process them all without really knowing what they are. I know they're MyDevices, but I don't know specifically what type they are. I just run their methods, in this case toString, but it could be calculate price, calculate shipping, or what have you, and I just run through the array and process them all the same way. And it solved the problem of how do I put different types of objects into an array. I create the superclass, MyDevice, and I make the array list of that device, so they all quote-unquote fit. So those are the steps you would use to create an inheritance tree and use inheritance in your programs.